Second half of section 13.3, use reference angles. All right. When we're dealing with all of these different angles on this circle, a lot of times it's helpful to use what's called a reference angle and figure the sine, cosine, or tangent of that angle, and then you can easily figure what the actual trig function is using the easy one. All right. The reference angles are found. A reference angle is going to be an acute angle that is between the x-axis and the terminal angle of theta. So, in quadrant 2, if theta ends in quadrant 2, if the terminal angle of theta ends in quadrant 2, then your theta prime is going to be this angle here from your y-axis up to the terminal side of the angle. And in order to find what the degree measurement of that is, you're going to take 180 degrees and you'll subtract off theta, and what you have left is your theta prime. Now the same type of thing if you start with pi, which of course is the same as 180 degrees. If you've got your if your theta is in radians, then you would take pi minus theta. All right. If your terminal side is in quadrant 3, then what you need is you want the acute angle between the y-axis and the terminal side. So you want this angle here that goes down below the x-axis. And so you want to take theta, all of theta, and you want to subtract off this 180 degrees. So if you take the whole angle theta and subtract off 180 degrees, then you'll end up with that theta prime. So that's how you figure the reference angle if it's in quarter 3. If your terminal angle is in, terminal side is in quadrant 4, then that means your angle has opened up all the way, almost all the way around. And so the easiest way to find this theta prime, which is going to be between the x-axis down to this terminal side, you're going to take the whole circle, the 360 degrees, and subtract off theta, and what's left is that little bit that is your reference angle. And so a theta prime is called a reference angle. All right, so the first section is going to be, it's going to simply say find the reference angle theta prime. So it will depend on how they give you the problem, whether or not you give them the answer in radians or degrees. All right, and what I have done here is I have deviated from the examples in the book because they are very simple. And so I'm giving you a little bit more difficult ones because when you get to your homework, they're not going to be simple. All right, so you're going to use your handy dandy unit circle. Hopefully you still have that. Don't lose it. It is your life. Well, not really, but it's pretty important. Okay. So if we want to find the reference for theta prime, first we've got to find out, well, where is which quadrant is the terminal side of this angle theta. So this angle theta is 7 pi over 12, and if you look, there is no 7 pi over 12 on this unit circle, but you can find out roughly where it is. You don't have to know exactly where it is. In this case, you just want to know what's the reference angle. And so what you're going to do is, this is 7 pi over 12. If you remember, with the unit circle, pi is 180 degrees, or halfway around the circle. All right? So what this says is 7/12 of pi. So we want 7/12 of pi. So 7/12 of this semicircle, right? And we know that 6/12 is halfway there. So 6/12 is going to be at your 90-degree angle, and so 7/12 is going to be right here. All right? And if you don't remember, if you don't know exactly where, it's going to be in there somewhere, and that's okay. So we know that this is in quadrant 2. And that's what we need to know. Because in quadrant 2, we know that to find a reference angle, we're going to take, because we're dealing with radians, we're going to take pi and we're going to subtract theta. So we're going to take the whole pi and subtract off this 7 pi over 12, and that's going to give us the angle that's left here, and that's going to be our reference angle. So we're simply going to take pi minus 7 pi over 12. And you know you've got to have like denominators when you subtract, and so you just make this 12 over 12. And now 12 minus 7 is 5 pi over 12, and that is your reference angle, and you're done. All right? Let's find one using degree measurements. Let's see. If theta is 295 degrees, what we're going to do is we're going to say, well, we start from here. We start at 0, and we're going to open. There's 90. There's 180. There's 270. We're not quite to 360, so we know we're in quadrant 4. All right? And that's all we need to know. We don't even need to know exactly where. We need to know it's in quadrant 4. And in quadrant 4, we know, hello, peekaboo. In quadrant 4, we take the whole circle, 360, and we subtract off theta to get theta prime. So we're simply going to take 360 and subtract 295, and our theta prime is 65 degrees. That's our reference angle. We're done. That's all you do on those. All right, so what you'll need to do is, and I think it might say draw a reference angle. So if you want to do, if they say to do that, and I think on the quiz I might say to do that, what you'll need to do is to show where that angle is, and then show this is where the reference angle wants to be. And 295 is going to be somewhere in there. And so this is your theta prime. All right, just to show that you know where it started. All right, use the reference angle to calculate the sine of negative 225. All right, so what we're going to need to do first is figure out, well, where is negative 225? So first we have to realize that with a negative degree angle, we're going to go clockwise around our circle instead of counterclockwise. So instead of using the degree measurements that are sitting there, we're going to have to kind of count. All right, so we want 225. So we start here, and we know that this is 90 and this is 180, and so then 180, let's see, I think each of these is 15, 180, 190, 200, let's see, 90, 180, 90, 200, 245 more. So that gets us to 135. So it's the terminal side is at 135 degrees. All right. So now, so this is like a two-step to get to the reference. All right, this isn't even actually the number itself. You're going to find the sine of this reference angle, and then you can easily find the sine of this. So what you're going to do is, your terminal side is at 135, so that's there. And so what we're going to do is we're going to take, if the terminal side is 135, that's going to be 180. Our reference angle is going to be 180 minus this 135. So that's 45, right? Okay, so 45 degrees is our reference angle. So at 45 degrees, the sine is square root of 2 over 2. The sine is square root of 2 over 2. And if I'm in the second quadrant, I look to see my sine is positive in this quadrant, and so this is my final answer. All right? And I can't remember, because I've had to redo some of the videos and I'm all confused, so I can't remember if I've talked about this ASTC already. A says that all trig functions in this first quadrant are positive. The sine is positive in quadrant 2, tangent is positive in quadrant 3, cosine is positive in quadrant 4. So that you can just quickly and easily see, okay, I want the sine and I want it to be in quadrant 2. So in quadrant 2, the sine is positive. And so what you'll do is you'll find the, step 1 is to find the reference angle. After you find the reference angle, then you find the trig function of the reference angle. Then you look to see what quadrant is that in to determine the sign. All right? So let's do one more. The sign, not this sign, but the positive or negative sign. Oh my word. Okay, cotangent of 5 pi over 3. Once again, a little bit more difficult type of a problem instead of giving you just something quick and easy. I want the cotangent of 5 pi over 3. So if I look, 5 pi over 3 is way down here. And so if I'm wanting to use the reference angle to find that, this is going to be since it's in quadrant 4, I'm going to take the whole circle and I'm going to subtract off theta to get my reference angle. So the whole circle is 2 pi. I'm going to take 2 pi minus 5 pi over 3. And so I'm going to get like denominators. So 6 pi over 3 minus, not equals, minus 5 pi over 3 equals pi over 3. So this is my reference angle. And then, so I've got my reference angle. So the cotangent at pi over 3, the cotangent, okay, the cotangent is going to be the flip of the tangent. The tangent is sine over cosine. The cotangent then would be cosine over sine. So the cosine, are you following all this? The cosine is the 1/2. And the sine is square root of 3 over 2. And so when you flip and multiply, you get 1 over square root of 3. And then when you rationalize the denominator, you get square root of 3 over 3. And then, you're not quite done yet. So this is your value, square root of 3 over 3. Then you look to see in the fourth quadrant, because that's where 5 pi over 3 is. In the fourth quadrant, is your cotangent positive or negative? Well, if the cotangent is going to be cosine over sine, it's going to be positive over negative, which is a negative. So this is your final answer. Okay? I know. You're saying, but it would be easier just to figure it straight. That's okay. You want to do this right now because later it'll come in handy, okay? All right, here we go. Last thing, of course, is I'm going to give you a word problem, and this is going to be oh so simple. You're going to love it. Okay, so you're going to kick a soccer ball at initial speed of 46 feet per second, and it projects at an angle of 30 degrees. How far will the ball travel horizontally before it lands? So we've got a ball that's flying through the air. We want to know how far does it go from here to there before it lands. And what you've got is a formula. In order to solve this type of problem, you're going to use a formula that mathematicians that are smarter than I have come up with by kicking lots of balls, I suppose. And they have used the gravitational pull on the Earth. This only works on Earth, so don't go and try this on the moon or Mars or anything. So the distance is figured by taking the velocity squared over 32 times the sine of 2 theta. Okay, so we're going to take the velocity squared. Well, the velocity, we know the initial speed is 46 feet per second squared over 32 times the sine of 2 theta. And theta is our 30 degrees. That's the angle that it's projected. So 2 times 30 is 60. The sine at 60, we simply go to 60, and the sine is square root of 3 over 2. All right, so 46 squared over 32 times square root of 3 over 2. Stick all that in your calculator, and you end up with, roughly equal to 57.3 feet is how far that ball travels. There you go. All right. So, yeah, I think reference angles, I know you can do this. You can do this. So find the reference angle and then determine depending on what quadrant your terminal angle or terminal side is in, that will determine whether it's positive or negative. All right. Good luck.